pause.
Hello, everybody. Happy Monday, and welcome back to 60 minutes of unscripted .NET content. Here on .NET Live, our mission is to help you, .NET developers, achieve more. I'm one of your hosts today, Katie Savage, here with Cam and Maira. Hey, guys. And today our guest is Hayden Barnes. Hey, Hayden. How are you?
Hey, thanks. I'm great. Thanks for having me.
Of course. We're super excited to talk with you today. Would you like to start out by maybe introducing yourself and letting us know what you're going to talk about?
Sure. So my name is Hayden Barnes. I'm a Windows developer MVP. I've got an interesting background I'll talk a little bit more about in Windows and Linux and cross-platform development, and then my career intersected AI. And that's what I'll be talking about today is cross-platform development with AI, using AI for various devices using the ONNX Runtime.
Oh, that sounds super interesting. I mean, AI is always something that we're down to talk about these days. So I'm super excited to hear more about what you have and more about the ONNX Runtime as well.
Yeah, me too.
Cool. Should we bring up your slides and get into it a little bit?
That'd be great. Yeah.
Awesome.
So currently I am the open source partnership manager at Hero Devs. I'll touch a little bit about my day job in a moment. Previously, I was the open source community manager at Determined AI, which was an open source project backed by HPE AI. Prior to that, I was a senior EM at Rancher. And before that, I was an EM at Canonical, where I worked on Ubuntu on WSL. So my history has intersected Windows, Linux, containers, AI, and that's what really led me to my fascination with cross-platform development and leveraging AI, like basically writing once with .NET, leveraging the ONNX Runtime, and being able to optimize automatically for a broad array of operating systems, architectures, deployment types. And that's why I'm so enthusiastic about this topic. Like I mentioned, I'm a Microsoft MVP in Windows development. Oddly, I probably do most of my development in Linux on Windows, but for me, coding for Linux on Windows makes the most sense. I enjoy, building applications for Windows and Linux at the same time. I'm also an ARM ambassador. Almost everything I'm doing today will be on ARM, except for one x64 example, just to show that it is cross architecture.
It works.
It works, yeah. And then I also wrote a book, Pro Windows Subsystem for Linux, which has been out a couple of years. And I mentioned a few places you can find me. I'll come back to this. We can come back to this later after the talk, so people can connect with me. In my day job, I work at Hero Devs on a project called .NET NES. We provide continuous ongoing security support for end-of-life .NET LTS versions, which is right now includes .NET 6. Those are security fixes for the SDK, the runtime, ASP.NET, various UI frameworks, and we provide a drop-in replacement for Windows and Linux. So
can let me ask you, so you guys actually write and deploy patches, security patches for out of support versions of .NET?
Yes, we do.
That's wild.
Yeah,
that's awesome.
So we monitor CVEs on upstream, 8, 9, and 10, and when applicable, we backport patches to 6. However, we also have our own red team strategy and identify our own security vulnerabilities. And as for those familiar with the process of reporting vulnerabilities, you are a registered CVE reporting authority. So, which we do quite often with our other open source frameworks and toolkits that we support. But we have actually reported CVEs on .NET 6, for example. We have 6 out right now. All high to critical, including one critical remotely executable privilege escalation in ASP.
Yeah.
So
yikes.
Yeah. Yep. So that's what I do in my day job.
Super interesting.
Yeah, it's fun. It's fun. So why we're gonna do an overview of my talk. First, I'm going to talk about why local AIML. We've all used Copilot or Claude or ChatGPT. What kind of use cases make sense for local AIML? What the ONNX Runtime is, what ONNX Runtime GenAI is, and then I want to touch on Microsoft's Phi model series, because there's so many models to choose from. But the Phi series is not only a great series, but it kind of gives you a sense of just understanding what Phi has in its lineup can help you understand like the various types of models there are. So we'll touch on that. And then I've got two demos that I'll show. I've got source code for one up, and one is kind of a work in progress, and we'll see how that second one goes. So why local AI/ML? A huge driver for this is security, and that's not wanting data to leave the premise, for various reasons. And in some cases, that's required by compliance with like regulatory requirements, industry standards, government regulations, in industries like finance, healthcare, if you're contracting with the government, if you're in some sort of security industry, you're not only might not be allowed to use, online AI, you might be in an air gap network. You might be sealed off. In the IoT and embedded space, your devices might have limited connectivity. If you're deploying small devices, and they may have intermittent LTE, they may have intermittent Wi-Fi, they might not get updated, once a month. Also, depending on your project size, your budget size, cost. Online AI can be expensive. So also, because we can, with the ONNX Runtime, it's possible to run many AI/ML tasks locally, even on resource-limited commodity hardware. So everything I'm doing today, I'm doing, I don't have like a fancy NVIDIA CUDA GPU. I'm doing it on the CPU on a Qualcomm Snapdragon processor. Nothing fancy. In fact, it's not even optimized for the Adreno GPU. But it is very possible to leverage ONNX Runtime and its GenAI capacity for discrete tasks on these devices.
And Hayden, can you quickly clarify? We have a question about what is the ONNX Runtime? Is it different from the .NET Runtime or Mono?
Oh, that's a great idea. Let's do that right now.
Wow, it's like we planned this.
Right. So the ONNX Runtime, the .NET Runtime is a great analogy because .NET allows you to take C#, F#, VB.NET, and a host of libraries, and then target multiple operating systems, architectures. The ONNX Runtime is similar in terms of conceptually. It is a runtime that allows you to make AI/ML workflows portable, particularly around inferencing, which is taking models that have already been trained and deploying them to do tasks like chat completion or image detection, audio generation. It can be useful for training in terms of building models, but it's really finely tuned for inferencing. Some other analogies to the .NET Runtime is that it's it supports multiple platforms. It supports multiple programming languages, C#, but also Python, C, C++, JavaScript, and it is relatively hardware agnostic. So once you port your AIML workflow to the ONNX runtime, relatively simple process. In fact, it's like basically built into PyTorch now, if that's something you want to do, and we'll talk about that a little bit more. You can then take that model and deploy it with the ONNX runtime, and wherever that is being run, it will optimize for whatever hardware you have available. So you don't have to ship a CUDA version. You don't have to ship a RockM version. You don't have to ship a DirectML version. In most cases, you can simply ship one version, and the ONNX runtime will, when it picks up your model and deploys, will see what hardware you have available and optimize the inferencing task for what's there.
So does this run in process with your app, or is it a separate process?
It embeds in your application.
Okay.
Yep. So
I'm
I'll
just
show
trying to
you.
understand, like, in terms of how you get started. Do you download like an SDK, a runtime thing separately, or like it's a NuGet package? Like,
Well, for our .NET fans, it's a NuGet package, and I'll
okay,
show you literally how simple it is to get started.
okay, that's awesome.
So, and there's a lot of like AI stuff happening right now in .NET, and we've got the new AI extensions, we've got the semantic kernel, and it's like how do all these things relate to each other? I know you recently had a guest on who was talking about semantic kernel. ONNX runtime is definitely at the lower level, and then kind of above that, we now have the Microsoft .ai .extensions, which can help piece some of this together. And then above that, you have like the semantic kernel that can like orchestrate everything together. But ONNX runtime is still useful to understand both conceptually, but also in terms of targeting for discrete tasks. Because let's say you're not necessarily building a massive workflow. You're designing. You have something like a Raspberry Pi type device that is doing image recognition, and you want to optimize for that hardware. Like ONNX runtime is an ideal candidate for being able to like test this on Windows and on a desktop, and then ship very quickly to an SBC type device, and not have to be too concerned about those resource like reconfiguring it for the device specifically. It'll run consistently across those devices. So yeah, you can easily convert models that you grab off Hugging Face to the ONNX runtime. There's plenty of pre-converted ONNX models on Hugging Face, including most of the phi models are available as ONNX optimized versions. Microsoft supports ONNX runtime. They also back Olive, which is an open source project for optimizing those AI models for ONNX. But there's third-party tools. There's even an option now built into PyTorch. So you can export a model from PyTorch into ONNX runtime natively. So it's become a standard for portability for AI models across hardware very, very quickly. So what is ONNX Runtime GenAI? ONNX Runtime GenAI is an extension of the runtime tailored specifically for generative AI tasks. Inference predominantly, some training. Because the ONNX runtime is so does so well in resource-constrained environments. The GenAI component focuses on SLMs, small language modules, for discrete applications. Now, we still call them small language models, but they now do things like audio recognition and image recognition. So it's doing more than just chat completion and working with text. But the ONNX Runtime GenAI builds on the ONNX Runtime cross-platform and broad hardware support to bring those GenAI tasks to life. So right now, ONNX Runtime supports Linux, Windows, Mac, Android, iOS is on the roadmap. You can support a broad range of models, anything from the Llama series or Mistral series, and there are hundreds, if not thousands of those, not only the official ones, but fine-tuned forks of the base models on Hugging Face, even more obscure ones like Qwen or new ones like DeepSeek. Hardware support is expanding. CUDA is there for NVIDIA hardware. DirectML is a great cheat if you're deploying on Windows, because DirectML will also leverage whatever you have available. And this is just the generative AI part. Like runtime already has support for a lot of these, but the generative AI part is still adding in some of these. QNN.
I've got an edge case that I'm wondering if it's supported, and it's that oh gosh, what's the name of it? It's the USB AI accelerator Coral that Google has. They have a little USB AI accelerator. Is that supported?
I haven't heard anything about that, but I would be surprised if someone wasn't working on it. If you dug into GitHub and found a PR somewhere, because there are some very obscure hardware platforms that are being optimized for the ONNX runtime. Yeah, so even things like Qualcomm GPUs and Intel GPUs and AMD GPUs are in active development. Many of these have landed in some sort of preview support already. All right, we're going to get to the code, and we're going to get to how we implement this very soon. I'm trying to cover some of the concepts without going too fast, but
No, and I think it's great because like a lot of people are new to this. I don't know ONNX, so it's like for me having that context and that before we jump in, I think it's super important. So I appreciate that.
No worries. Microsoft has released a series of originally SLMs, but have now expanded to a broad range of models called the Phi family. These are open source. They're MIT licensed, which means you can use them in your production applications. They were currently in the Phi-4 generation. So if you see in language, you see Phi-4, Phi-4 mini, and a new multimodal language model. We also have coding completion. We now have vision and vision recognition. As we move, it seemed like last week we were all talking about agentic AI, and this week we're all talking about MCP. Like it changes so fast, but in terms of like agentic AI functions, 5.4 got function calling. So your AI can work with your APIs on your behalf. 5.4 also got audio support and reasoning support. So in terms of kind of understanding the types of AI models that are out there, seeing what the Phi-4 family has is a good way to understand, okay, there's language models that do text completion or chat. There's coding models that do coding completion, and even now like agentic coding fixes. You have specifically vision models. You have function calling models that can be implemented in agentic workflows where you want the AI to figure out what to do, but then interact with your APIs or third-party APIs to make things happen on your behalf. You have audio models. You have advanced reasoning models that can not only kind of give you the answer, but kind of explain how they arrived at an answer. If you use Copilot in Edge, you'll see, if you chat with Copilot, there's an option now that it used to give you the quickest response, but there's now a think deeper response that takes about 15 to 30 seconds longer. But that's powered by more advanced reasoning, and it actually does. It literally stops and thinks more about the answer it's giving you. So yeah, that's a great way to think about the overall landscape of where many of the models are using the Phi family. And the Phi family is a great place to get started using models. The other thing is that the Phi models are a basis for the Phi Silica models, which are the SLMs that are built into Windows on Copilot plus PCs. So if you grab the new Surface laptop or the new Surface Pro, or one of the existing like Lenovo, which is my favorite, the T14S Copilot plus PC, and you run Windows updates, you will see like monthly, you get like an updated Phi model that's built into Windows that is doing your on-device AI/ML tasks that are optimized on that Copilot plus PC. So you can work with the same models that are being shipped in Windows, but use them pretty much anywhere. And if you're interested in working with the Phi models, I highly, highly recommend the Phi Cookbook, which is on GitHub and is regularly updated, and is not only multilingual in terms of speech, but multilingual in terms of programming language, and has got tons of great code examples to get started working with the Phi model, in most cases with ONNX Runtime or ONNX Runtime GenAI. So yeah, have we had any good questions come in so far that I can stop?
We have a couple. A lot of them, I think the everything you were talking about with ONNX marinated a bit. So we have some good ONNX questions if you're down for
Sure.
a couple of those. Okay.
Yeah.
One of those from Cecil is asking, can we run ONNX models using tools like Ollama and Docker Model Runner?
So like Ollama is an interesting, like I like Ollama for like being able to quickly grab a model and run an experiment with it and not have to worry too much about like configuration, juggling context windows or anything like that. I do think you can use ONNX models with Ollama, but I would see ONNX more as a way to get models that you've then like fine-tuned for your particular purpose or embedded into your application into production. So if you're a .NET developer and you want to provide like a helpful chat interface for like working with your application or doing audio recognition as part of your application, ONNX Runtime is a way to get there. Whereas I see Ollama more as a way to just kind of like just download and play with models.
That makes sense. A couple more while we have your attention here. One from Wesley is, what kind of file format is ONNX, and does it use a particular embedding?
What kind of file format is ONNX? So when you convert models to ONNX, you get a .ONNX and a .ONNX .data. Does it use a particular embedding? I need more clarification on what he's seeking there.
Yeah, let us know in chat, Wesley, what you mean,
Yeah.
and if you have any follow-up there, and we can ask a little bit later. Another question that came in is, can we run transformer architectures on ONNX Runtime like we do with CNN architectures?
Yes. Yep. You absolutely can.
Nice. That was an easy one.
Yeah. Yep. Transformers are fully supported.
Cam, Maira, are you seeing any others in here?
So our mutual friend Jeremy asks, which models do you recommend for the best balance between speed and efficiency?
I like the Phi star 3, now 4 mini instruct models. These models are not going to give you paragraphs and paragraphs like full Copilot or Claude or ChatGPT. They're going to give you a good paragraph, but they're going to be able to execute quickly, 30 to 90 seconds on unaccelerated CPU hardware. You can go larger, if you have access to hardware acceleration. They're definitely there. But the mini instruct models in the Phi family are very useful, and we'll see in my demo. So in terms of getting taking a Phi model and getting it into production in your .NET application, you're probably going to want to fine tune it. Let's say you take the language module or the multimodal text model, and you're in a business that an example I like to use for this is you work for an insurance company, like a claims auto insurance company, and instead of hand reviewing every police report that comes in on every car accident, you want a model that can quickly scan a police report and write a summary for the adjuster. You will then take a set of these police reports, and you're going to want to tell the model, look at this part of the text, and you're going to train that model. So you can grab something small like Phi-4 mini, a set of data like the police reports you're looking at, and maybe some target parameters you're looking for. And you can use the AI toolkit for Visual Studio Code to do all of that. It allows you, it's an extension. It allows you to download the models. It allows you to set up your input data. It allows you to specify your kind of output parameters and fine tune your models before pushing them into production. It's got a playground that lets you, sit there and tweak things to get the best output, helps you generate prompts. And even if you need synthetic data to train your model on, let's say you don't have police reports to start on, it's got a data generator to help you get started with that. It can do that both locally or in the cloud if you have an Azure account. It will leverage Azure Container Apps. So that's kind of like the next step, like, all right, I want to put this in my .NET app, but let's say I need to train it on my app's documentation. You could use the AI toolkit to take, 5.4 mini instruct, fine tune it on your documentation, and now you can embed a helpful chat app in your application to assist users. So here's a quick example. You can grab local models, remote models. You can select by task and model types. You can check to make sure they have fine-tuning support. And back to the question is I think this now supports Ollama in addition to ONNX, but a lot of the work under the hood is ONNX based. So leave time for demos. .NET, you have your cross-platform application runtime. With ONNX, you have your open source AIML runtime. With the ONNX Runtime GenAI, you have an extension for GenAI tasks built on the ONNX Runtime. With SLMs, which aren't just language anymore, such as the 5.4 series, you can manage language, vision, audio, function calling, and even do advanced reasoning. And then you can take those off-the-shelf models and then fine-tune them using the AI toolkit for Visual Studio Code, which uses the ONNX Runtime to do this, and fine-tune those off-the-shelf models for your .NET application.
I think people do want to see that we're getting lots of questions, but it's like
right. So how do you incorporate the ONNX Runtime GenAI into your .NET? It is literally .NET add package Microsoft ML ONNX Runtime AI. You add it to your header, and it's about 10 to 15 lines of C#. So let's take a look at that. I'm going to share my whole screen. You're going to briefly see backstage because I don't have two monitors, and I'm sorry about that. I'm a one big monitor guy. And then lower that. So this is an application called gnomephichat. It is a simple JTK3, which is a predominantly Linux UI framework chat application. And how visible is that code? Do I need to enlarge it?
it looks good to me, but people can let us know if it's not large enough. Please comment.
Yep. So what you'll see here in my project file is first I'm targeting and I'm using .NET 10 Preview 3. I'm importing the JTK UI framework, the ONNX Runtime, and the GenAI component. I'm ensuring that my model that I've downloaded makes it over when I publish.
Some people are asking to enlarge just a tiny bit more.
Yeah, I can absolutely do that. Appearance. View. Appearance.
Control plus will work too.
I know.
You're a clicker.
Well, it doesn't. It's a different thing in Terminal where I spend a lot of time too. So
got you.
No worries. So what you'll see here is most of my program is just setting up the JTK interface. XAML never clicks for me. Maybe one day it will. I prefer programmatic interfaces programming, but we'll come back to that. In terms of what you actually need to implement the generative AI aspect of this, we have our model downloaded here. It comes with some configuration files here. But in our actual code, we simply define our model, tell it where the model is located. We set up a tokenizer based on where the model is located. We define a system prompt. Here, I gave it kind of a high-level prompt in that, you're an AI assistant, you're helpful, answer questions directly, do not share information that's more than requested. Sometimes I've added, do not hallucinate here. But then we launch, we do some more interface stuff, but we simply start our session, enable DirectML if it's available, set up our model, jump through that, add our tokenizer, do some error checking and error handling. Really, this right here is the bulk of the work. We take our full prompt, which is a combination of my predefined system prompt and the user's question. We encode that to the tokenizer. We set our generator parameters. We give a maximum length. We decide whether or not we want a share buffer. And then we submit that to the tokenizer. And then while the generator is running, it computes. We grab each token, add it to an array, and then once that's complete, we give an answer. I know some of the concepts can be new, but the code is relatively about 10 to 15 lines. And once you understand the concepts, they're pretty straightforward. So I have a example of this. So this is a cross-platform application. So I am going to run it here on Windows. So this actually just isn't just running on Windows. This is running on Windows. This is an x64 application running on my ARM PC because I'm on my ARM PC right now. What is the phi model series? So that'll take a second because, again, this is a resource constrained device. There's no fancy NVIDIA, 5080 here. We could actually go take a peek real quick at Task Manager and see what's happening behind the scenes. It's hitting the CPU pretty hard, and it's going to jump in memory. I could tune that down with config settings. But we're going to let that run. At the same time, I want to show you what I have running here is the exact same code running on a Ubuntu VM on x64. It is literally a Git clone of the same thing. And
people were asking, does that use a lot of GPU?
So neither one of these are optimized for GPU. So they are CPU and RAM dependent. They can be optimized for GPU. You can, in this demo, I haven't recompiled anything for the Adreno GPU on the Snapdragon hardware, but you could. But what I'm trying to do is show the baseline performance at on resource constrained hardware, and that it is possible to perform these tasks That's not expected.
It happens. It's a live demo.
That's not expected. Well, I wanted to wait. I said, wait, let's go see what's going on behind the scenes here. Resources. Oh, you've got plenty.
I was gonna say because
and here we got our answer.
Yep.
So yeah, completely on device, no GPU needed whatsoever. Now, can it be optimized further? Yes. Can these be tweaked? Could you recompile ONNX Runtime GenAI to take advantage of specific tasks? Yes. Can you grab and enable settings to optimize for the Qualcomm NPU in Copilot plus PCs? That's available. Is RockM and OpenVINO support landing? Yes. But my point here is to show what's happening at a low level in the resource constrained environment. So our Windows one's actually running a little slower. It's doing a lot of CPU, and it's having to transcode a lot of that because we're on ARM, and it's executing a whole host of x64 that has to be just in time translated to CPU. And so we'll give it a second. Any questions right now?
Oh, we have tons always popping up today. It's been lit.
Okay.
Yeah. So Major Porkins was asking because he got it in the middle of the stream. So do you have a repo that people can go look at this sample code that you're showing?
Yes. gnomephichat is up on my GitHub. Let's see, will it let me? There we go.
And you can hide that pop-up if it's in your way as well.
Yes. Let's do that. So it is here.
We can put it in the chat.
Yep.
I'm hearing beautiful bird noises from somebody.
Yeah.
And I have crows outside, so I'm getting the
It's like it looks like someone is in the middle of the nature.
I'm jealous.
So
not here. I hear airplanes from LAX.
So here's an example of why we don't always trust AI. What is the 5 model series? And I was hoping to get an answer about the model series from Microsoft, but instead we got an answer about smartphones from Xiaomi, which is interesting. But hey, it happens.
It's an interpretation.
It's an interpretation. It's an interpretation. All right, so that's one demo. That was one thing I wanted to show, that you can build the same app for Linux and Windows. You can do it very simply in about 10 to 15 lines. Most of that code is UX. It runs on Linux and Windows the same way, whether it's x64 or ARM. And that's like a nifty start. Okay.
And people were asking like about MAUI and ASP.NET Core. Like if it's a NuGet packet, it can use on any kind of .NET applications, right? Like
yeah. I'm just, for context, I'm a systems guy. Like I'm a terminal guy. Like my default is to write a terminal application or a service, not a UI. So, which is probably why XAML never clicked for me. I want command line flags. But yes, this can very much be implemented not only in interfaces like Maui and ASP.NET, but also in things like, applications powered on Aspire. So, which is new and exciting. But let me show you another little thing I've been working on. This is, if I can get it to, let's put that away. This is a little interesting project I put together. This is a terminal assistant. Like I said, I'm a big fan of the terminal. And again, running .NET 10 to preview the latest. And what I've basically done is swapped out the error handling in Ubuntu on WSL on my system for a little application. It's actually a Windows application that gets called from WSL that looks at what I typed, what I've been typing, what the error message was, and submits it to, in this case, phi-4, so an upgrade from the chat app. And it uses a more recent version of the ONNX Runtime. So it's got a slightly different set of API calls. You'll see it looks similar to the chat app, but there's a little, in fact, it's somewhat simplified in a way. But basically what I do is I source a bash script that traps error signals in bash and then routes them to my application, which then uses that along with the context that's passed by the shell script. I have a system prompt that says, "Hey, you are a helpful and funny AI assistant who are assisting Debian Ubuntu users, and also you're invoked when a command results in an error, and you're here to provide advice on what the correct command should be. Provide concise, one-sentence answers only, nothing lengthy. Do not guess. Do not hallucinate. It is important your answers be applicable to Debian Linux, which Ubuntu is a Debian derivative. And then my user prompt is also programmatically constructed. There's no like chat here. I basically feed it the last command and the error message and ask, what should the command be? I compile that full prompt, launch the tokenizer, generate the parameters, launch the tokenizer stream, feed that through, set the max length. Here I actually do use a share buffer so that if I get repeated errors, the model has some context for what's happening. I create that array, iterate through that array, writing out the response to the output. Again, fairly simple, but let's take a look at that in action. So as you see here, it's just a .NET app, builds pretty quickly. If you see in my bash RC, I'm simply sourcing the shell script from my project, which is of course on my D drive, my Windows dev drive, as always. But let's see it in action. So let's do something incorrect. Apt install htop. Let's leave out the sudo and see what happens. So the error message is it couldn't acquire the lock file. This is common if you run apt without sudo or administrative privileges. The error gets trapped by my script. Oops, something went wrong. Let's call Terminal Assistant to help you out. And it is generating that system prompt and that user prompt, and then calling the AI to give me an answer. Hey, the command should be sudo apt install htop. So that's super useful. Let's, it could even be something as simple as let's just go rogue and say, how do I sync my computer's time? Obviously, that's going to be an error on the terminal, but believe it or not, the AI will usually figure it out and give you an answer. So things I like thinking about here is not only assisting your users with their application, but making it seamless and not have to jump through hoops and how they do that. And also, when we get into, because I'm more of a systems guy, I think a lot about integrating these kind of tasks into systems and like going beyond just a terminal assistant, but having like a service that periodically analyzes on Linux like systemd logs for patterns and can run periodically, analyze those, and provide perhaps reports on optimizing your system configuration. And with ONNX Runtime, not only can you make those cross-platform, but you don't have to be very concerned about the hardware that your service might be running on, because if it's got CUDA, it's going to find CUDA. It's going to use that NVIDIA GPU. It's got ROCm. It's going to find it. It's going to use it. If it's CPU only, it's CPU only. And with an SLM like this, it's actually not that slow, and it's all local, so you check those boxes in terms of security and compliance. You're not feeding your system logs, to a service. There's some that we can trust, but there's some you might not trust or be allowed to use. So actually, so in this case, just asking a question like on the terminal gave us the answer. But let's see.
That was awesome. You didn't even have to leave the terminal to search for it, right? Like it's right there.
Let's see. Let's make a mistake here. All right, I left out sudo and I misspelled microcates. So the point that I wanted to get across is ONNX allows you at a low level to build cross-platform and cross-architecture applications. You can then, give me the correct command right there. You can then embed these in your existing .NET applications with 10 to 15 lines of code and make them super helpful. You can then if you're shipping applications to end users or to endpoints with the ONNX Runtime, you don't have to be super concerned with the hardware that it's going to run on, because it will leverage what's available. And I want, app developers who are developing for end users to be thinking about, how can I leverage AI, not just for like the cool AI stuff we all see, but like, how can I leverage AI to make my app, more usable, like to, help a user. So like a user who's supposed to type something or do something, let's say they just get frustrated and just ask my app the question. In this case, it actually just gave the answer. Or if you're in systems programming, how can you leverage generative AI to optimize, the performance of your Kubernetes cluster, or, your process logs from, systemd, to check for performance enhancements. These are the things that excite me. So I'll pause here and we can go back to questions.
I think we're like, I have to agree with Jose here. Like, can we have a bit more time for QA? Like, this hour went by so fast. We had so many questions and we couldn't get to them all. Apologize about that, but it was an amazing session. I agree. I love it.
And I guess, Hayden, where can people follow up with you about these questions? Is there a place outside of the stream they can go to get their questions answered?
Yes. So you can find me on Twitter. I still call it Twitter. Still trying to get that. It is at Unix Terminal.
Let's put your slides here. Let's see. Do you have?
Yeah, we have that. It is. Let's go. I'm at Unix Terminal. You can connect with me on LinkedIn. You can also drop me an email. Also, if you like WSL, or you just want to ping me on Telegram, just find me on Telegram. WSL.community. We've got a Telegram channel. A lot of the big WSL MVPs and other hackers are in there. But you can reach me in there as well. And you can find it by just going to WSL.community, and it'll give you the Telegram link. I'll be at Build next week. So if you're coming to Microsoft Build, I will be around. I will have tickets to the Hero Devs party. We've rented out a whole arcade for everyone to go to on Tuesday evening. So find me, find the tickets.
And Katie and I will be there too. So
okay, you're invited.
So...
You're invited. You're invited.
Awesome.
So yeah.
Awesome. That was great. And yeah, and maybe we can have you for round 2 of this. I think people really dig into, and there were more questions that we couldn't get to.
Great. All right. I guess, unfortunately, I think we have to close out. Although everyone, like Hayden said, direct your questions to him on Twitter, or all of the other places he listed. Hayden, thank you so much for joining us today. I think that was an amazing stream. I know I learned a lot. And thanks everybody who's been watching, either if this is your first show or if you're often tuning in to on.net. We really appreciate you, and continue to check us out here on YouTube or all the other places you're watching from. We won't have any other shows until June, I believe. We have a little bit of a break, but
yeah, we have Build, and
we have Build,
Memorial Day coming up.
and
so
many things happening. Yeah, but we'll catch you all soon, and I'm looking forward to it. But thanks, everybody.